Hi all, let's see the next topic of Unit 2, Control Memory. Coming to the contents, we are going to discuss about an introduction to what is a control memory, and then we will see in detail about microprogrammed control memory. So coming to the introduction, as we already know that the CPU, the central processing unit of a computer, it is partitioned into arithmetic logic unit, control unit, and a memory unit. So we already know that arithmetic logic unit is responsible for performing arithmetic and logic operations, whereas the memory unit is responsible for your storing your data as well as the instructions into your computer. So the next is the control unit. So the function of a control unit is to generate the relevant timing and control signals. So it overall controls the flow of data between the CPU, memory, and the peripherals of the computer. So this control unit, it has to communicate with the arithmetic logic unit and the memory unit of the computer as well as the input output peripherals for the smooth execution of the instructions and program, right? So the control unit coordinates all the other remaining part of the computer and it instructs the arithmetic logic unit what type of an operation has to be performed. So, as we have already discussed, the control unit generates the control signal using two approaches. One is using a hardwired control unit and a microprogrammed control unit. It can be designed in two ways. When you are designing the control unit using a hardwired control unit, hardwired approach, in this case, it is designed using hardware circuits such as your multiplexers, decoders, encoders, flip flops. Using this, you're going to design your control unit. But coming to the next type of an approach, which is a microprogrammed control unit. This is a software approach where your control unit is designed using a software program. But you're going to write a microprogram which is responsible for generating the control signals by the control unit. So when we look at the control memory is a part of a memory that is present in the control unit in case of a microprogrammed control organization. Okay, so any computer that involves a microprogrammed control, mainly it consists of two memories. One is the main memory and other is a control memory. We already know about a main memory where we store our instructions as well as your data that is required to execute the particular instructions are stored in the main memory. Coming to the control memory, it consists of microprograms. So these microprograms are fixed and they cannot be modified frequently. But if you see the instructions and data that are stored in the main memory, they are not fixed. Depending upon the execution of the instructions, the data that is stored in the memory unit of a computer, it may change. So you can modify the data which is present in the main memory. But coming to a control memory, the microprograms which are stored in the control memory, they cannot be modified frequently. They are fixed. So these microprograms which are stored in the control memory of a control unit, they contain micro instructions. And each and every micro instruction, it can specify one or more micro operations. Okay, so we have already seen different types of micro operations, right? Like logic micro operations, shift micro operations. So these are performed by the micro instructions which are stored in the micro program of the control memory. So the machine instructions, so each and every machine instruction of a program, actually the instructions of a program are written in a high level language, and once they are compiled, they convert into a machine code or a machine instruction. Each and every machine instruction, it generates a chain of micro instructions in the control memory. So in order to execute any machine instruction, the particular micro instruction which is stored in the control memory has to be executed by the CPU in order to execute the machine instruction. So the main function of the machine instructions is to generate micro operations that can fetch the instruction from the main memory, that can compute the effective address, execute the particular instruction, and once the execution of this particular instruction is completed, then the control has to go back to the fetch phase and continue with the execution of this instruction according to the program order. So that is the main function of the micro instruction which is stored in the control memory of your control unit. So let us see this with an diagram. So if you see here, this is a control memory. Here the control memory is typically considered as a ROM, read-only memory. So as we already know what is a ROM. ROM is a read-only memory, which means that you can only perform a read operation on the contents of the memory. You cannot update or write. Once the contents are written into the ROM, they cannot be updated. So that is the reason we call it as a read-only memory. So whatever the information that is stored in the control memory, microprograms, they are fixed and they cannot be changed at any moment. So once a control unit is designed, it cannot be modified at any point of time. So the micro instructions are stored in a control memory, typically ROM. And we also have a control address register, which contains the address of the micro instruction, which is being executed by the control memory. Okay. So the control address register holds the address. So all the micro instructions are stored in the control memory at a specific location of the memory. This is just like a main memory. So control memory also contains different locations. Each and every micro instruction is stored at a particular location in the memory. So whenever the CPU wants to execute a particular micro instruction, a particular address of the instruction is stored in the control address register. So by looking at the address in the control address register, it goes to the particular address in the control memory, fetches that particular instruction from the control memory and stores it into the control data register. The particular instruction that is fetched is stored into the control data register. So control data register holds the micro instruction that has to be executed by the CPU. And there is one more thing here called next address generator, or we can also call it as the microprogram sequencer. So next address generator is nothing but when the current address is being executed by the CPU, it is the responsibility of the control memory to fetch the next address of the next micro instruction that is stored in the control memory. And that is the responsibility of the next address generator or a microprogram sequencer to find which is the next address that has to be given it as an that has to be stored in the address register so that a particular micro instruction can be fetched. So that is the use of a next address generator or microprogram sequencer. So here the control is presumed to be the read-only memory where all the control information is stored permanently. And control data register, it stores a micro instruction that is read from the control memory. So the micro instruction is stored in control memory in the form of a control word. We call it as a control word. It consists of a control word that holds one or more micro operations. Control word or a micro instruction, it can perform one or more micro operations on the data. A next address must be computed once this operation is completed. So this is done by next address generator. Then the particular address which has been computed by the next address generator is sent to the control address register. So that the control address register reads a particular address from the control unit and put it into the control data register. The next address generator is also known as microprogram sequencer. So based on the inputs to a sequencer, it determines the address of the next instruction. So what is the next instruction that has to be stored in a what is the next address that has to be stored in the control address register depends upon the multiple inputs. It receives multiple inputs. The sequencer receives multiple inputs. Based on the multiple inputs, it decides which is the next address that has to be loaded into the control address register. So the function of the microprogram sequencer is it can increment the control address register by one. So or so if my control address register contains address 1000, so the next address can be 1001. So it increments the control address register by one. That is one approach. The other approach is it can load the address from the control memory to the control address register. So it can be any address, not 1000. It can be 2000. So the particular address from the control memory can be loaded into the control address register. It need not be according to the program order. And one more thing, it can transfer an external address or load an initial address to begin the start operation. So, for example, if it is the start of the particular program, then it can be a starting address where the first micro operation is stored in the control memory. Maybe the starting address is 0. So that can also be loaded into the control address register. So it can be anything. It can either increment the contents of the control register, or it can load the address from the control memory to control address register, or it can load with an initial address to begin the start operation. So these are the functions of a microprogram sequencer. So here the data register, we also call it as a pipeline register because it allows two operations to be performed at a time. It allows performing the micro operation which is specified by the control word. So whatever a micro operation which is specified as a part of a micro instruction, that is also being performed on one side, and other side the generation of the next micro instruction, next address of the next micro instruction will also be done in parallel. So that's why we call it as a pipeline register. So this is all about control memory. Thank you.